Hello, this is Information Processing Group 6, and we're going to present our Church Sprint project, which is a tempo run light game.
One key aspect of our setup is how we handle game state synchronization. Since multiple players are interacting at once, we need a system that updates positions and events efficiently while preventing desync. To achieve this, we use network interpolation and prediction techniques, allowing smooth movement even if there's a slight network lag. Another important element is dynamic level generation. Instead of preloading everything, our level manager spawns obstacles and track segments on the fly, making sure the environment updates based on the player's progress. This helps optimize performance and memory usage. On the back end, we also have state persistence, which means even if a player disconnects, their progress isn't lost. Data is stored in DynamoDB, allowing us to track scores, session data, and even potential analytics for future improvements. One area we're looking to refine is latency reduction in multiplayer interactions. Right now, we're testing ways to improve real-time updates, potentially using different data compression techniques, or optimizing server and client communication for lower ping.
As you can see, I'm in the game. Simply turn right to go right, turn left to go left, then the top button to jump, bottom button to slide.
For FPGA design, after integrating the accelerometer, button, and 7-segment display using Platform Designer, we developed C code and Python script to print out raw accelerometer data and button values from the FPGA on the host computer. After that, we set up a TCP server that acts as an intermediate between FPGA and Unity. Thus, the server receives data and WebSocket sends it to Unity, while Unity sends scores back to the server and display on the 7-segment display.
This is a quick rundown on how the Unity client processes data. It first takes accelerometer data from the FPGA server and sends this to the player script. The player script then uses this data to translate the position of the avatar on screen. It also sends the score to the canvas, which is displayed at the top of the screen. The multiplayer client receives messages and sends messages to and from the AWS server. It uses this data to update the positions of other player avatars on screen, all whilst the level manager manages the track and handles events by loading objects dynamically and managing the queues.
So this is one of the Unity clients. As you can see, as I move here, you can see it on the other client over here. Same goes if I move here. You can see the avatar move on the other screen as well. This is the AWS server, showing all the update position messages. And see if you press R, both are ready. So you see I can play on this screen, see the score increase. Right, I'll just keep going. Obviously this one will die, game over. And as you can see, we have the high scores loaded from the database here. This is without the FPGA. The FPGA manages the tilt. This is purely a test of the Unity client.
So now on to the leaderboard system. The leaderboard system tracks player scores using AWS DynamoDB. The main components include the server node.js file. This is the core of our game server. It handles the player connections and game events through WebSocket. Then the next important file is leaderboard_db.py. This Python script manages the database operations. What it does is it saves player scores and retrieves the top scores from DynamoDB. Now, to make these two previous files work together, we need a bridge file. So this is where leaderboard_python_bridge.py comes into play. This file connects our node.js server to the Python database. It allows the server to call Python functions for adding and retrieving scores. All these three tie in together to then fill the server_leaderboard.json file. This is the local file where scores are stored, and it gets updated automatically whenever a player dies, and their score is recorded. To summarize, what this does is, when a player dies, the server captures their score, saves it to the database, and retrieves the top scores to display back to the players. This ensures that everyone can see the leaderboard in real time. Overall, this system enhances the competitive aspect of our game and keeps players engaged.
Hello, this is Group 6, and this is our game. Action.